All right. So let's get rolling. I'm pretty sure, just take a couple minutes, and I think everybody got some sort of email yesterday about university's thing for coronavirus, that kind of stuff. Um, my understanding is if you're traveling somewhere over spring break, that is a bad place to travel uh, by what a CDC level 3 or whatever thing. When you come back, you have to self quarantine for 14 days or something like that. I think it tells you to let the university know or something, but if you're in that situation, if you're, well, I guess the official university thing is we're to encourage you not to travel to places like that, but the world is what it is, and sometimes you're traveling home or something, and you might be in an area where it's, there's already widespread virus stuff. So if you're in a situation where when you come back, you are needing to self-quarantine for the 14 days or whatever, just let me know, and what we'll do is I guess my opinion is that the university might end up having all classes remotely anyways, so we should be prepared for whatever ends up happening. But worst case, or let's say at the very least for us in here, what I'll do is I'll turn class into I'll do a Zoom meeting live here and share the screen. So if you're at home, not able to physically sit in class, you can sit at your desk at home as if you're sitting in class and see my screen, and I'll record it and everything like that, so you can still come to class live. So just keep me in the loop. The same thing, I guess, is going to go for me. Although I think that problem is going to take care of itself. I'm supposed to leave for a cruise on Sunday. So I think the email faculty members said something about if we're going to one of the CDC level 3 areas like China or Italy or something like that, or a cruise, I think, or any cruise. Yeah. That we have to self-quarantine when we come back. So very likely I'm not going on this cruise anyways. At this point, it's like a game of chicken. My wife and I are just waiting until the cruise line cancels on us. Because if we cancel, we just get a voucher for a future cruise. If they cancel on us, we get a refund plus a voucher for a future cruise. So we're holding out for the better deal. But I think any way you cut it, it's unlikely that my cruise is going to happen. But in the event that I also have to quarantine, I'll do the Zoom meeting from at home. So at that point in time, I wouldn't necessarily expect that you have to come and sit in class and watch the Zoom, but class will resume via Zoom, and we will continue to have class in the normal way. So I think that for your computer science classes, at least, this should be a relatively easy thing to work with. But I do wonder how some other departments, like if you're in a... Yeah, well, not even just that. I mean, some classes, like if you're in an art class where you're doing ceramics, I don't know if that translates to online all that well. So in any case, keep your eyes open on university email and things like that. I'm also supposed to tell you from the cafeteria, if you have any of your self-fill bottles and stuff, they will not let you fill those in the cafeteria from this point until, I guess, whenever. So even water and things like that. So, I mean, I think they wouldn't let me bring my mug I bought from them today to fill it. So they're taking precautions there as well. So try to be respectful of the different rules. I know it's inconvenient, but it's, let's say, for a good reason. We'll see if it ends up helping or not. But at the very least, I know there's going to be some inconveniences in your life moving forward. So try to be respectful and understanding that they're not meant to just punish you. It is what it is. So everybody cool with all those things, I guess. So we'll stay in touch and see what happens. But know that at least from my class perspective, if you are in a situation where you aren't able to attend class in person, we will, or I'm not able to attend class in person, class will still go on in a digital format. All right. So let me quickly go over the homework assignment for today. I went ahead and solved it, and I'll just talk through it real quick so we can kind of turn our attention back to classes. I do anticipate having all the exams done today for grades. Again, I'll remind you that if you did poorly on the exam. I know some of you have reached out and shared that you're concerned that you like didn't earn points and things like that. So again, don't worry if you saw the exam when we went over it on Monday and the answers made sense to you. You're in an okay place. Eventually, you'll start being able to do it on your own. Right now, you're probably spending a disproportionate amount of time on homework related to the number of lines of code you actually end up writing. Just the nature of the beast for programming. Just stick with the process, and I promise eventually it'll click. I will let you know if I think you're in a situation where it's just not happening for you and maybe this isn't your cup of tea. Similarly, if you have seen the for instance, the answers to the exam and they still didn't make any sense to you, or you aren't able to go back and walk through it and make some sense out of them, set up a meeting with me and we can chat through it. But you know, programming's not for everyone, but at the very least, I'd say don't freak out yet just because of a poor score on an exam, because that's going to happen, and that's exactly why I let you replace the midterm with the final. Plenty of situations in the past have happened where somebody got like a 15% on the midterm and then got a 90 on the final and replaced the 15 with the 90. All right, so you're, stick to the plan for now. All right, questions about any of that stuff? All right, so let's look at, I just went ahead and put a version of the problem for today was our last regular expression problem dealing with strip, where strip is a function for strings that if I just kind of come down here real quick, if I have a string S that has some spaces, like this, and then I were to print out S, and then I were to print out S dot strip, notice I get the string with all spaces before and after removed from it. All right, so here's my original string that has a bunch of spaces prior to the LOL and a bunch of spaces after the hello. So stripping that removes all those leading and trailing spaces. That's what the strip command does. There is an optional thing with strip where I can, put in, let's say, a couple of question marks here, and I can say I want to strip on question mark, and it will remove just those characters, the starting and trailing special characters that I want to remove. But the important thing with strip is it only removes stuff from the beginning and from the end. Notice it didn't remove spaces and stuff in the middle. If I randomly throw a question mark there in the middle, that guy is still there after calling strip. So strip just removes from the ends. Okay? So we understand what the strip command does in general. All right, so they asked us to create our own version of strip as if that function did not already exist, if strings didn't already have that ability, that used regular expressions to, along with the sub function for stripping white space or spaces from the beginning of our string. So what I did here is I took in a string that we wanted to strip, as well as the strip string. So this guy took in a parameter, and I don't know if you didn't do this, this is okay, because they asked you to write actually two versions of strip, one that took in no parameters, that just did exactly what the default version of strip does, which is just tear away white space. And then a second version of it, which is similar to this guy that says, hey, I want to be able to tell you what characters I want to strip. Okay? So in Python, we're able to have parameters that if you do not give it, it will have a default value. So in this particular case, this function is taking two parameters, a string and the strip string, which is assumed to be spaces unless you provide something else. If you didn't do this version of it, that's okay. So if you just did the version, I think in the question it asked you to challenge yourself, do the second part of it. If you didn't do that part, that's okay. All right, but just showing it to you here. So if I don't provide the second parameter, it will just default to a space. I want to remove spaces from the beginning. All right, so I created two different regular expressions using the idea that we have a way of having a regular expression matching everything at the end, and we have a way of a regular expression matching everything at the beginning, not necessarily matching things throughout the string. All right, so this first regular expression, I'm looking for whatever my strip string is. So by default, this would be just a space. So the default for that would be that guy. The collection of characters containing just spaces. Or the collection of characters containing whatever I passed in here. All right, so I'm looking for this collection of characters, at least one of them, at the end of my string. That's what the $sign says. Look for this pattern at the end. This other one here says look for that same pattern, at least one of them, at the beginning. Make sense? Two different regular expressions, one that looks at the end, one that looks at the beginning. The first one, I'm going to set my answer, so the result, I'm just putting it inside of a variable called answer, equal to my regular expression calling its substitute function, and I want to substitute a empty string, not a space, but an empty string, within S for anything that matches this regular expression. So that means that anything that is a space, I'll go ahead and put my spaces back in here. So it'll match all of, well, actually the first one is end, right? So it'll match all of this stuff and replace that with nothingness. That's what it'll do. It'll substitute those spaces with double quote, which is the empty string, the string with length 0. Make sense? Similarly, and then I'll store. So this guy will boil down to whatever S was with all trailing spaces replaced with the empty string. So this guy will ultimately, it will not change S. It will instead boil down to a brand new string that is S with all trailing spaces removed. And I'll store that answer inside of answer. Then I'm going to use my second regular expression, which is looking for spaces at the beginning, or whatever my strip string was. But the string I'm looking in is now my string called answer, my slightly modified version of S. Right? Answer is my version of S with all the spaces at the end removed. So I'm going to pass at that guy and say, I want you to replace, so substitute, an empty string for anything that meets this pattern. This pattern says any spaces or anything that's in the collection of characters inside of strip string from the beginning. I'll overwrite answer with its new version of itself, which should now have the front spaces removed. Now I can return answer. So if I say print strip on S, oh, hold on. There is my string with all the spaces at the beginning and all the spaces at the end removed, which should do the same thing as the default strip function does. So here's real strip and my version of strip. Go ahead.
Would you have been able to combine the regular expressions into one, or would that not have worked?
No, you could have. Yeah, you could have said match anything at the beginning or at the end. Yeah. This kind of is from the chapter in the book, and I think I mentioned on Slack, and I mentioned last class, I'm going to start moving away from, I've decided I hate the book. Anybody double down on that? Does anybody else hate the book? Yeah, so I'd rather do more in-class examples and then have you operate off of them, but, you know, we're too far in to replace the last 7 weeks, but one of the things that I think the chapter on regular expressions is okay in the book. I just think the sections in the book have too much fluff with not enough individual things where I think our examples in class are more targeted. And then when we got off a class, that it kind of puts you at a disadvantage, having to do homework without seeing an example in class. So we're going to try to fix that in the second 8 weeks. I think those of you who've already seen my answers to the my grading for the homework assignment for the formatting one, whatever it was, that assignment was just, that sucked. So I'm just giving everybody full credit, no matter how bad your solution was. It was just a bad assignment, is what it is.
So are all the assignments still going to be from the book?
They're actually not. I'm switching them. In fact, if you look right now, I still have the same number of assignments, but a bunch of them switched to like to be determined. So I'll cover something in class, then give you an appropriate assignment relative to what I covered in class. So really, this semester I tried to use something that's different than the way I've taught the class in the past, and now I'm just going to go back to the way I used to teach it. Is what it is. Go ahead.
Quick question: what does the F indicate in the white space and white space begin?
Yeah. So this is our format string that we looked at, I think, last class, that allows us to say, I'm building a string and I want this guy to be a placeholder for whatever strip string is. So it's a replacement for concatenation. It allows us to do concatenation more easily. Now back to your question. The book kind of indicates this is how do I handle complex regular expressions? My experience, this kind of goes with what I've said all along in the classes. Solve a problem in the way that makes sense to you first. Don't try to get fancy. So you can try to write this, in this case it wouldn't be anything crazy, but you can try to write the more complex regular expression, or you can just say, I'm going to do this in two swaths. I'm going to remove the end stuff, I'm going to remove the beginning stuff, and then I'm going to have my answer. And I think that more times than not, that's probably okay. If you're writing something that is very mission critical, that has to be as fast as it possibly can be, you maybe wouldn't want to do 2 passes, but for something like this, I think it's when you're stripping off the leading and trailing spaces, I think you're not really looking at speed, you're looking at convenience. I'm cleaning up this string so I can do some other stuff with it, that type of thing. So I would say every single time I would write this like this. If I was in a job where I was working with regular expressions day in, day out, where I was like super confident with them all the time, maybe I would look at this as still a simple regular expression to match the beginning or the end, and write it as a combination, but I think this is a pretty reasonable approach. Other questions on this? Go ahead.
How would you combine two? So you put a dollar sign and the carrots, this is the whole string.
Yeah, so I think what you would do is you would, there's examples in the book where you would match it with an or. So you would say match this pattern or this pattern. So then I would just include this in the second half. I want to match either of these patterns. Let's see, we'll just take out this. I'm not going to spend too much time debugging it, but I think this is roughly what I'm matching here. So did this get my... Actually, it seemed to match neither. So let's see. I want to match... So I won't do the or. I'm going to say I'm going to match 0 or more things at the end. Here, we're actually going to switch this around. 0 or more things at the end, followed by, or at least one thing at the beginning, followed by 0 or more anythings, followed by the thing at the end. We'll just pull it off. Isn't question mark anything, or is a period anything? I just got rid of everything. Yeah, because the pattern I want to match is oh, it's going to match the whole string though. So I did get some matches there. This is saying match everything at the beginning and substitute or match everything at the end. Can I remove both? I can't say the same thing twice here. Yeah, I have to think about that some more. Because you're basically saying I want to replace all spaces that either exist at the beginning or all spaces that exist at the end. So you would need to incorporate an or in here. I thought this is how you represent the or, but I wonder if you need to do two different groups. So you would need an or. I'm just using the syntax incorrectly here. There we go. So there's a group for it. Yeah, you have to use groups when you're using an or, otherwise it doesn't know where one begins and where one ends. I still think the other one's better, just using two separate ones. I mean, you saw I had to sit there and screw with it for a couple of minutes until I kind of got the right little thing where it's pretty easy to say, find everything at the beginning, and then as a completely separate train of thought, find everything at the end. So here, let me do this. I'll comment that out so you have it as a example. And then I'm going to steal this. And we'll put just my end back in. Okay. So I'm going to give this to you as the proposed solution. But I'll go ahead and give you the comment that has your kind of combined regular expression if you want it, if you want to study that. I would never ask you a question that would ask you to write a really complex regular expression. What I want us to get out of this class, and regular expressions are things that in a former life I probably used pretty often when I was doing Unix system administration, but it's something that I'm fairly rusty on, but you can see how powerful they are even in their simple cases for substituting things and pattern matching. So even with just a little bit of competence with regular expressions, you can do some fairly powerful things. I would never ask you to do some crazy regular expression. In fact, I probably on an exam wouldn't ask you to, I probably wouldn't even ask you to write a regular expression, because I feel like regular expressions are one of those things where right now, if you had the documentation sitting in front of you, you can kind of mess with it for a little bit till you match the pattern right and then get it working, but it's not really a programming specific skill set as much as it is just a tool that you might buy from Home Depot, and if you use it once every 3 years, you have to kind of relearn how to start the lawnmower. Like you got one of those specialty start ones or something like that, and you kind of have to remind yourself how that tool works. But then from that point forward, for that summer, you're going to mow your yard pretty efficiently.
Overgrown lawn, though.
What's this?
That's one overgrown lawn, though. You don't only mow it once every 3 years.
Well, that's true. That's true. Well, now I want to get one of those robotic lawnmowers. But the question is how do you keep somebody from stealing your robotic lawnmower? Because they're supposed to park itself and charge itself, and then it just goes and mows the yard whenever it thinks it needs it. And you set it up and it just robotically mows your yard, and then it puts itself back in its charge thing. But what keeps somebody from going and just taking it, running off with it?
Maybe it has an alarm if it leaves the premises.
Yeah, I guess maybe. Or to text you and said I've been stolen, and then you call the cops and say somebody stole my lawnmower. No, I mean, maybe the thing is once it parks, it locks itself there, and there's some sort of way of mounting the charge station. So it's only vulnerable when it's actually out moving with a spinning blade, so kind of use at your own risk type thing. If you want to try to steal a self-propelled lawnmower while it's cutting grass.
Add some extra spinning blades on the side.
Weaponize it. I think you might have some lawsuits from local pets or something like that. Somebody's dog comes limping home because it got a little close to your robot lawnmower. Yeah, go ahead.
You put a tractor in it.
Oh, a tracker? Yeah, well, yeah, then it's just like the cars, right? Somebody stole my car.
If it were to leave the area where it's designated, it would send an alarm to your phone, it would track it,
Well, I'll do something like that on vacation sometimes, because I could start my car from anywhere. I have an app that will talk to my car. So like if I'm away on a trip, like for instance, like it seems likely I'm not going to be traveling, but let's say I was in Florida all next week and we have an ice storm here. I might go ahead and start my car remotely. It'll stay on for like 15 minutes just so it warms up so the ice melts off while I'm gone so it doesn't just drop down to 5 degrees and I come back to a sheet of ice on my car. That kind of stuff. But so we have the technology now where you can track where something is, like find my iPhone or find your laptop or something like that. But at some point it's going to be kind of funny when you call the cops and they would have put an APB out on tracking down your lawnmower. Yeah.
So I just looked it up, and it's like a Find My Lawnmower. Like you have an app, and it's like Find My iPhone. So it just gives you a notification when your lawnmower is still like.
Is this specifically for the robotic ones or like anything for any lawnmower?
No, this is specifically for the robotic ones.
Okay.
And then it will automatically turn off if it's picked up.
Oh, well, that kind of sucks. Yeah. Yeah, way better if it automatically turns on. This kind of reminds you, like, I remember many, many years ago, there was, this was a technology thing. I want to say this was a different time, but we've had plenty of examples in human history where we've done some really dumb things that sounded like a good idea at the time. But I think this was in Israel, and they had a pretty major problem with like carjacking. I think this is a problem in a lot of big cities, anyways. But there was like a 6-month period of time in Israel where it was like a major issue. People were getting carjacked all the time, where people just coming up and gunpoint, get out of the car and stealing your car. Well, somebody came out with this like security system specifically for this, where you just hit a button, and it was like horrible. There was like 2 different versions. One like sprayed them with like acid, okay, and the other one like doused them in like lighter fluid and lit them on fire. These were real products. It's a car. Let them steal the car. Everybody's okay. You'll go to jail and you get a new car. It's a major inconvenience, but I'm not sure you light them on fire over it.
Fire sounds like a good way to get in.
And they had videos of people like just melting from acid in the streets. It was terrible.
I bet the carjacking stopped.
It did. Because there was always a risk that person might have one of those. It probably at least stopped on the really expensive looking cars where you figured that person might have that system in place. If they had a not so great car, maybe it was they figured out they probably don't have the acid blaster.
I was gonna say, going back to the lawnmower, you can make it way more.
Well, and I think naturally, battery operated things would. So I think that was the thing, like with the Tesla Cybertruck thing. One of the reasons why it could out pull like a Ford F-150 or something. Part of it is that electric engines have a lot more torque. But the side effect is that the Cybertruck weighs a lot more because of all the batteries that are in it. So it's not exactly a fair fight. You're not really comparing the engine to the 2 engines to each other. You have something that weighs like 5 times as much as the Ford does. But that's true. You can basically have it like work like Thor's hammer. Where they go to try to pick it up, the thing weighs like a metric ton. They bring it to your house and install it via forklift.
It only weighs that much if you're not worthy.
That's right, if you're not worthy. All right, so questions about this implementation of Strip? Make pretty decent sense? Go ahead.
Is there any reason to use this over Strip?
Probably not. This is more of the idea that you can create things like this. This is practice using sub. So you can make things like this using regular expressions. Because you might want to go through and, this is kind of practicing doing things in the beginning and the end. But let's say that you wanted to get rid of, let's say you have like a big document, a file that has a whole bunch of like weird special symbols in it or something like that. Or you wanted to replace all, here's a good example. So if I'm sending emails to everybody in my classes and I want to do it with my normal email client versus do it with Blackboard, send an email to everybody in the class, if I go to Banner and I say send all email, it doesn't put the email addresses in the right format. It has them, I think, comma separated, and my email client wants them to be semicolon separated. So I can have a quick regular expression where I paste that string in, write the regular expression that substitutes all commas with semicolons, and now I have it in the right format. So, just the idea of substituting one character for another or a series of characters for something else, I think are, a good thing, a good tool to have, right tool for some jobs. So again, the whole idea, the original idea of using the book that we're using for the class, which I don't think is all bad. I just feel like as we get deeper into the book, there's too much reading and not enough example. So it's going to get worse. So I figure this is kind of a reasonable stopping point as we start getting into classes. But the idea being, if you're, I like the premise of the book from the automate the boring stuff, because if we're thinking about computer programming at the basic level, I mean, as beginning programmers, our limitation is we're probably not going to sit down and write a video game, right? We just don't have the experience yet or the ability to work with such a large project in order to accomplish something like that. But you want to still feel like this tool you're learning is useful at some level. So even using that little example of, sometimes I want to send an email to 30 people, and I can either go through by hand and replace each comma with a semicolon, or I can write a quick regular expression. And if a quick regular expression, you have enough experience with it, only takes you a minute, that would be less time than it would have taken you to go through by hand and do all those things. So kind of starts letting you use that power tool to your advantage as you're a inexperienced programmer until you can start doing more impressive things. Make sense? Kind of like how in the show Smallville, Superman, before he got all of his powers, it really helped, his strength helped him with the farm work, even though he couldn't do the laser beam things or fly. He couldn't fly till the very end. Did everybody see that show? It's a great show. That's the way a Superman show should be. It's fun when he can just fly day one and start just, being awesome. But what if you had like light superpowers? How might you use those early on? So just think of that as a programmer. You're basically Superman light. Okay, so let me paste that real quick in Slack. And then let's go back and talk about where were we at on time? Okay. Then let's go back and talk about classes a little bit more. Okay. So let me go back here first. We talked about this last time, so I'm just going to review this to drive this point home for the need for classes. So first of all, we want to think about dictionaries not necessarily being a bad thing. If we need to hold a collection of information about something, but it's just a whole bunch of name-value pairs, like a human being. Maybe they have a first name, they have a last name, they have an age, they have a social security number. So if we just think about those records that a doctor's office or something might keep, dictionaries are the perfect data storage type of format, right? They're a nice, convenient way we can have a single variable name that holds on to a dictionary that holds a bunch of name-value pairs. Nothing wrong with that tool. We're not going to call that a tool that, we just used it for the first 8 weeks, we're never going to use it again. Super powerful tool. But for some problems that we might want to solve, we might say a dictionary doesn't quite solve the problem we're interested in having it solve. It doesn't do enough. So one of the things I mentioned here last time is the idea of the weakness of dictionaries is that it's really great at what it does. It can hold name-value pairs. But it doesn't have the ability to do anything more than that. And sometimes, as we've been practicing using functions, so if we, let's kind of get the other side of this coin, a function, what would you say a function is? Give me a reasonable definition for functions. Anybody? What is it? Why would we write one? Go ahead.
It's like a collection of code that you can use multiple times.
Okay. So a chunk of code that we write once and can call multiple times with different inputs producing potentially different results. All right, so we can think of a real life example of a function as like a blender, right? So we have a blender at home where we can push a button in it, spin something really fast. Now we get different things out of a blender depending on what we put into, what inputs we put into the blender, right? If I put, yogurt and bananas and fruit juice and things like that, I'll get kind of a smoothie type thing out of there. If you put in a bunch of almonds, you're going to get like kind of crushed up almonds, right? You get different outputs given what your inputs were. Even though the logic, the thing it does inside the blender is the same. It's just being applied to different inputs. That makes sense? So a function is like that. If we might want to, in our real life, we might say, you know what? I sometimes want to be able to blend things. So I'm going to buy a blender, but I'm not buying a blender for just this single purpose. You might even have a common purpose for the blender. Maybe you make a lot of smoothies. So the blender is for that common purpose of smoothies. But even within that, you change up the kinds of smoothies you make, right? Maybe it's a small strawberry smoothie some days and more of a green-based smoothie another day. So you're still making smoothies, but the inputs to your blender are a little different and it's producing a similar yet not identical output. That makes sense? So we bought that blender because it was a generic tool that allowed us to solve a common problem for us that isn't always using the identical inputs. All right? Where you go out and buy a lawnmower, these things are built for, the generalistic practice of mowing yards, but at the same time, grass comes in, some different densities, different heights. If you have a normal push lawnmower and you've let the backyard get out of control where you have 3-foot high wild grass, a regular lawnmower might not cut it, pun intended, right? So you might have to bring in another tool first to chop it down to a certain level. So that tool isn't made for everything, but it kind of covers a broad range of inputs. It works for grass of a maximum height and a maximum density. All right, and probably not something that has a whole lot of extra surprises in there when you're going around and all of a sudden you hit a piece of metal or a stick or something like that was in there. It's, that's, in the best case, you now have a randomly flying projectile. In the worst case, you've now damaged your lawnmower because the unstoppable force hit the immovable object and now something broke, right? But that's the idea of a function, is we have this task that we might want to apply to different kinds of inputs. And we want to write it one time, giving us the ability to feed it different inputs, and it potentially giving us different outputs depending on what those inputs are, right? So we would say functions are handy. The job of a programming language is to allow human beings to solve problems in a very similar way to the way we solve them in real life. And many of us will have blenders, toasters, microwaves, things that we put all sorts of different kinds of inputs into and get outputs based on it. Certain things we put in a microwave, we expect a reasonable output. Other things we put in a microwave, we might not necessarily expect it to work out that well, right? Those are things we might use a different tool for cooking. But functions, this idea of having a reusable chunk of code that we can apply the same logic or the same solution to different outputs, is a very powerful thing for us in programming. All right, so does that make some sense? Does that kind of give you an idea of where functions fit in our problem-solving world? So when we kind of put it in the context of how many functions we've surrounded ourselves with in real life, we can kind of appreciate how powerful functions are, right? So now what we have is we have this disjointed example. So if I draw a picture here, we have dictionaries. And we have functions. And each one of these are powerful in and of themselves, right? So for instance, we might keep a list of friends' names and their phone numbers. That's something that is for our eyes only. We're storing data, right? And I might want to have a collection of first name, last names, and phone numbers. Dictionaries are great for that. Similarly, we might have a smartphone, and this guy can do it stores a bunch of stuff, right? So we have our contact list in here. We have our collection of apps, where an app has a name and then a binary and executable associated with it. So we have all sorts of things in there, but there's a bunch of functions. If I say give me the top 3 things you do with your smartphone, all of us can come up with 3 things pretty quickly. And we know if you had to give me a bigger list, you can give me a bigger list of functions that your phone does for you, right? And for most of us, the phone call aspect of it probably falls farther down the list than it should, right? Most of us would probably buy the better portable computer than the one that can make the better phone calls. None of them even talk about phone call clarity anymore. Nobody cares about it, right? We're voice chatting or whatever with other tools now. All right, so in and of themselves, these 2 tools are powerful tools. But we can imagine if I want to have something like a smartphone. We might expect this guy to encompass both of those tools. So we want a smartphone to have the abilities of having dictionaries in it, among other things. Among the other types, we might have lists and strings and all sorts of stuff, but just keeping our, the eye on the prize right here. We want it to have dictionaries, but we also want it to have built-in functions. And we're going to call this a class. All right? So a class is now a tool that object-oriented languages give us. Python including Java, C#, all of our modern programming languages are typically object-oriented languages that give us the ability to create this container that can hold, at the very least, name-value pairs and then other things. That make sense? Okay, so that's the tool we're working with here. When we talk about a class is a collection of class, and usually they're called class members, where a class member can be a field, a constructor, or functions. And in the context of object-oriented languages, typically functions are called methods. They're synonyms. So you'll hear me probably interchange those terms, functions, methods. If you go historically, if we think about the historical names, we have subroutines, functions, procedures, methods. I don't know if I can think of any more right now, but all those things are basically the same thing. Some older languages have created some differentiation. So for instance, in like the language Pascal, which was actually a language specifically designed to be a teaching language and then became popular enough because people were learning it in school that they renamed it Delphi and it became a actual production language. But in that language, functions were things that returned a value. Procedures were things that didn't. Okay, and remember, we've kind of put this emphasis in here on this idea of the difference between returning a value and displaying a value, or doing something other than returning a value. All right, so not all functions will result in an answer. Some will just do something. Make sense? So the idea here is that in an older language, they decided to have two different structures to accomplish those two different tasks. Either doing something and returning a result, or doing something and not returning a result. Modern languages commonly just say everything's a function, or if it's an object-oriented language, they say everything's a method. These are synonyms, and they are reusable chunks of code that accomplish something and may or may not return a value. That makes some sense? All right, but any way we cut it, a class is a collection of these things: fields, constructors, and functions. So let's give some definition to each of these. What is a field? A field is a variable that holds information about an instance of an object. So in our example, I think I was doing like fraction stuff, right? Yep. So for instance, if I have a fraction class, we might have fields, numerator and denominator. Now, if I had a piece of paper that listed 20 fractions down on it, I had 1/2, 1/4, 3/8, whatever, I look at each of those fractions, I know all of those are fractions. They all are instances of the fraction class, but each one has a distinct collection of two values. Each one has a numerator, the top number, and each one has a denominator, the bottom number. So if I'm creating a class to represent a fraction object, I want to be able to represent this idea of a fraction in my project, I'm going to create a couple of fields, one for the numerator and one for the denominator, because every single fraction needs to remember that information about itself, right? I might have one fraction whose numerator is 1 and whose denominator is 2, and I might have another fraction whose numerator is 3 and whose denominator is 7. All right? Those fractions, the class itself was built generically, just like functions are written generically, but I would provide it with different values for its fields, in this case, different values for its numerators and denominators, to make it function differently. If I'm working with the fraction 1/2, that will have different results when doing math with that than if I'm working with the fraction 3/7, right? You get different values out of it, even though they're both fractions. All right, so I'll just start the slide here for constructor, and we'll pick up with constructors next time. So we're going to finish giving the definition to our objects, and then we'll finish writing our fraction class as an example before we go on spring break. I won't have homework over spring break. There's no homework for next class. I want to kind of catch us back up. So your next homework assignment will start post spring break. All right? Questions, comments, concerns, bribes? All right, I will see everybody on Friday.